arithmetic progression and geometric progression. Introduction of arithmetic progression. Learn Introduction of arithmetic progression, common difference, term. Hello students, our new learning object is arithmetic progressions. You may have observed that in nature, many things follow a certain pattern, such as the petals of a sunflower, the holes of a honeycomb, the grains on a maize cob, etc. In our day-to-day life, we use to some mathematical patterns like Reena has been offered a salary 7,000 by her boss with annual increment of Rs 500. Therefore, her salary will increase annually in the following pattern. Amit has a saving box. He started to put Rs 5 per week. In this way, money has been increasing every week in the following pattern. Now, to understand arithmetic progression properly, let us take an example of the staircase. We observe the staircase through front view. Now the rabbit is on the first step and will climb up the staircase as per the instruction. We will note the number of staircase on which he will jump. Jump 1 step. Now jump 2 steps. Now jump 3 steps. Jump 4 steps. What we have seen and noted? We have seen on each instruction added 1 step more to its previous and told rabbit to jump. The pattern we get is arithmetic pattern, but not the example of arithmetic progression. This is a square. We can write in number as 1 square. Add 1 square more. We get 2 squares. We can represent it as 2 square. Then add 1 more square in these 2 squares. We get 3 squares. In this way, each time we add a square, we get the following pattern. This pattern is known as arithmetic progression. We defined it as an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. This fixed number is called the common difference of the arithmetic progression, that is AP, and is denoted by D. It can be positive, negative, or 0. Each of the numbers in the list is called a term. We denote first term as A1 or A, second term as A2, third as A3, and so on. Therefore, we can write common difference D is equal to A2 minus A1 is equal to A3 minus A2, and so on. In all these lists, we can see that successive terms are obtained by adding a fixed number to the preceding terms. Again, we can observe one important note that the terms of arithmetic progression are arranged in the form of A plus D, A plus 2D, A plus 3D, and so on. This is called the general form of an arithmetic progression. This is an example of a finite arithmetic progression, as a number of terms in this arithmetic progression are finite. Finite arithmetic progression has a first term as well as the last term. This is an example of an infinite arithmetic progression, as a number of terms in this arithmetic progression are infinite. An infinite arithmetic progression does not have last term. Are we able to form arithmetic progression if we know first term A and fixed difference D? Yes, of course. Let us try some arithmetic progressions. Here, A is equal to -7. D is equal to -2. Now first term is therefore we write -7 as A. Then second term is A plus D. Add -2 as D and we get -9. Now third term is A plus 2D. To get third term, add -2 in second term instead of doing A plus 2D. We get -11. Then we get fourth term. Add -2 to third term, we get -13 and so on. Similar way, if we follow the steps with A is equal to 1.0 and D is equal to 0.1, we get 1.0, 1.1, 1.2, 1.3 and so on. Summary. In this chapter, you have studied the following points. An arithmetic progression, that is AP, is a list of numbers in which each term is obtained by adding a fixed number D to the preceding term, except the first term. The fixed number D is called the common difference. The general form of an AP is A plus D, A plus 2D, A plus 3D, and so on. A given list of numbers A1, A2, A3, and so on is an AP. If the difference is A2 minus A1, A3 minus A2, A4 minus A3, and so on, give the same value, that is, if AK plus 1 minus AK is the same for different values of K. So that is all about this subtopic. We will learn about term of an arithmetic progression in our next topic. Till then, keep learning.